horizontal. So these leads to actually over provisioning and under provisioning most of the times. So even in some papers, they have used vertical scaling along with predictive approaches, which is the best combination. Though it is the best combination, they have approached it only using one particular prediction technique. So my statement is that one particular prediction technique is not suitable for all these types of job arrival patterns. So these are the main problems that that I understand from the literature survey. So my motivation is to use vertical scaling, because vertical scaling in which we will be able to provide resources in a most granular level. So what I actually need, that much resource can be provisioned. So it motivated to use the vertical scaling. Another one is the hybrid prediction model that needs to be used. That means we need to first identify what type of incoming workload pattern is receiving. So based on the pattern, need to select a prediction model and then it is to be applied. So in this way, the above said problems can be avoided, like over provisioning and under provisioning, and then prediction accuracy in some cases. So these are the problems that will be addressed using vertical scaling, predictive scaling. In predictive scaling, using different predictive methods for different type of workload patterns. So this is my proposed architecture. Here I have hosted all the containers in the host operating system. So once it is running, its metrics being collected using the monitoring and metrics collection system, which is stored in the data warehouse. I used here InfluxDB, which is an open source database. Especially, it is designed for to store and analyze time series data, right? So, and here I have a knowledge database wherein which I will keep on updating all my data, all my historical data as well as the real-time data will be updated in the knowledge database, which is used to update my models. So basically, and this ERP, efficient resource provisioning system, is my research contribution. I'll be explaining that in detail. So based on its output, the resource scheduler will automatically scale using vertical scaling method. Right. So in metrics collection, I'll be collecting this container name, ID, for how long it is running, what is the assigned resource of that particular container. So what is the current status and what is the current consumption, current CPU and memory consumption. So all these details are collected and it is being pushed to data warehouse. Right. So data warehouse is just shows the data, and then in ERP system, I am using 3 different prediction algorithm. One is ARIMA and linear Gaussian SVM for linear SVM and Gaussian SVM for predictions. So here is my architecture. Like once the metrics is being collected using the monitoring system, I will analyze only the last n observation to identify the workload pattern that is coming in. So based on the workload pattern, so if it is a growing workload pattern, then I'll use the linear SVM. If it is bursty, I'll use ARIMA model, or if it is on off a random pattern, then I'll use Gaussian SVM. So after that, the accuracy is also calculated using the evaluation model. And finally, the resource scheduling happens. So that means the vertical scaling that happens. So first, the approach that I am using is, first I'll find out whether the incoming workload is busty or not. Right. So for finding that, I am using sample entropy. So sample entropy, if it is close to 0, then it means strong burstiness is there in the data, right? If otherwise, the loop continues, right? So if it is busty identified, then I'll apply ARIMA directly. If it is not, then I'll find the seasonality analysis using Lois package. So this will decompose the time series data into trend, season, and residual actually. So in that I am analyzing only the trend. If it shows any increasing or decreasing trend, then it is treated as growing workload pattern. So I will use linear SVM in that case. So if it is not bursting and if it is not growing, then obviously my else part will go to the Gaussian SVM portion. So I'll predict using these three algorithms, and finally computing the accuracy using MAP and MSE. So here I consider my performance metrics as prediction accuracy, prediction time, and then obviously CPU utilization and memory utilization. This obviously will be deciding the operational cost of the data center, right? How efficiently I'm using the CPU and memory. And this prediction accuracy and prediction time. So if I predict correctly, then only I'll be able to allocate the resources accordingly. So obviously these four will be the performance metrics to evaluate my proposed system. So in this, I have used the real-time traces from BitBrain's data center to train and test my model. So I have tested the model, and here are the MAP and MSE values. So these are the performance metrics parameter I have done for different workload patterns using the predictors that I have selected. So, and this is the prediction, how it happens for CPU usage prediction and memory usage prediction using ARIMA model. This is for bursty workload using ARIMA model, and this is for random workload using Gaussian SVM model. So, and then I have also computed the prediction time. So in this case, prediction time is not just prediction time, the consolidated prediction time. It includes the prediction of incoming workload also. So obviously when there will be a overhead of selecting the correct prediction methods to use. So it is the consolidated prediction time for different algorithms that I have used in my work. So to conclude, so this system, instead of going blindly for a single prediction algorithms for all different workload patterns, as we are deciding different workload algorithms. So basically, any prediction algorithms will not fit for all type of workloads. So that is why in this work I have proposed different machine learning algorithms to predict the workload based on the workload type. So in this way, the accuracy of the system has improved, so that the CPU utilization and memory utilization is also been in control, which will be helpful for the data center operators. So my future direction in this area is like how I can combine both horizontal and vertical scaling. I found in certain places in which this vertical scaling cannot help when compared to the horizontal scaling. Like when there is a sudden burst in the workload, the vertical scaling may take some downtime to adjust the resources. So maybe in that time we can switch to horizontal also. So my future direction of work is like how we can efficiently combine these two scaling techniques, and then integration with the most popular containers orchestration tool called Kubernetes. So currently I am working on in this area also. So I thought of integrating this work with Kubernetes also.
Yeah, I have one question.
Yes, ma'am.
You have mentioned about the workload patterns, right? So you're
Yes,
for 4 different workload patterns, you are using the prediction model, different prediction models, and
yes,
you say that instead of using one prediction model, you are using different prediction models for each and every workload. So in that case, will not the overhead increase if you're going to use
that is
multiple
what
models?
the overhead, that is what
Ah.
we have seen in the prediction time. So prediction time, it includes both identification of incoming pattern as well as the prediction accuracy. So that is why the trade, in order to achieve a trade-off, I have selected only last 50 observations from the metrics, so that the both accuracy and prediction time is not lost.
Okay, then what is the threshold that you're fixing for saying that your accuracy is good and you're able to do within this particular time period of time? What is the threshold you have fixed for both?
Yeah, actually, I have not fixed any threshold. Maybe I have compared with other papers only.
So have you shown that comparison in the graph with other papers for the existing models?
That is
And
not actually
because you
included.
have to, when you talk about accuracy and time parameter, you should say that your parameter, I mean the measurement that you have done, and say that your accuracy is good. That should be compared with some existing parameter, right? So then only you can conclude that yours is accurate.
Yes,
Can
yes,
you get
ma'am.
the point?
Yes, ma'am. I can understand.
So it's better to compare with the existing work
Yes,
and
yes, ma'am.
prove that yours is accurate, or the time prediction time is also better than the existing one. Okay, so that is my
Yes, yes.
suggestion.
Sure, ma'am. Thank you. So actually, in this paper, I have not included the comparison, but anyway, in my research, that I need to do that.
Okay,
I can
okay, fine.
understand. Yes.
Okay.
Yeah, Vigneshwari, the
Yes.
presentation was good, and I'm seeing that a lot of promising things are happening from your side. But one question that I will ask, the primary question that I will ask is, you're trying to bring more granularity to the measurement, right? So you're trying to have more and more containers over there, and then increase the containers, and then try to have Docker effect through which you can measure things and then solve the problems. But too much of smaller things also creates problems with respect to maintainability, right? If you have too many granular things, then someone has to maintain in all these granular things also, right? And there
So
might be dependencies also.
granularity,
Yes, sorry, go ahead.
granularity, what I mean is, in granular level, we'll be able to uh, tune the resources that is used by the container.
Okay.
Say, for
So which,
example,
yes, go ahead, please, sorry. Are you there, Vignesh?
hello, sir.
The too much of
Sorry.
granularity will also create problems, right? That is what I was asking.
Hmm.
When you try to have too much of granularity, it's an issue. And we are comparing the different models. That is good. But
Hmm.
each model has its own application. And how do we generalize all these models for a specific data set that you have, and then try to implement those models and see how things are there? Each model, did you find the application of the each of the model? What is the appropriateness of application of each of the model? And then you applied those things for your data, or you randomly took only these models?
No, based on the survey, I have selected these models for these particular workload patterns.
But does it fit your data? That is what I want to know.
Yes, sir.
How do
That
you,
is what the accuracy says. But I have
because
not
each,
compared in this paper. But if you see the accuracy value, it is very, the error is very minimum. MAP and MSE values are very minimum.
okay. Can you find out what is the reason some other models are not good for your data?
Um, yeah, maybe that comparison, like I am using, if the workload is growing, then directly I'm using linear SVM. Maybe the comparison I can do, like for growing, I have to use all three models, and out of which I have to prove linear SVM is better.
Uh,
That is what we are meaning to ask.
better in what sense? Because see, when you
Accuracy,
say better,
accuracy, good in accuracy.
which means that again it might be CPU utilization might not be so good in your model, right? So what I'm talking about is
CPU
the trade-off.
utilization.
You're talking about the trade-off, right? So something is
The
improving,
trade-off
something
between
is not improving.
accuracy and prediction time. The trade-off is
Okay.
between accuracy and trade-off time. For that, the number of datas I take into account, that matters. So if I select more number of data, then accuracy will be high, but prediction time will be high. And if I select very less number of data, then accuracy will not be that good, but prediction time is less. So in that case, there is a trade-off, so that I selected some 50 observation, last 50 observation into consideration.
Okay. So the number of observations that you consider is very less. You are saying that it's only 50.
Yeah. That is doing real-time prediction. For training the model, I have used the entire data set of that big brains real traces.
Okay.
So training happened with large number of data. Only during the real-time prediction, I have used only the last 50 observation in the real time.
Okay. Did you in the training, once you start training and then doing testing also, you will do testing also, right, over there? So what was the accuracy that you received in that testing? Any percentage that you got?
That is what I have shown in the map and MSC values now, sir.
Oh, that is for the prediction, right? Is it only for the testing or the prediction? Because over there you said it is for the prediction.
It is for the prediction.
So prediction, you're calling testing itself as a prediction over here, and then you're trying to find the accuracy over there. That's it, right?
Yes, sir. Yes.
But did you apply for any live data after that?
So the real-time prediction, as I said, it was conducted on the real-time containers only. So actually, I'm working in CDAC. We have a OpenStack based cloud environment here. So in this, I am running containers, and the workloads are simulated, and I'm collecting metrics out of it, and in that I am doing the real-time prediction.
But how are you using Kubernetes over here? What kind of libraries are you using for Kubernetes?
So Kubernetes in this paper I have not used, but in my work here I have used to manage the containers.
Okay.
So it can schedule provisioning, it can do elasticity like scaling, migration, everything can be done using the tool.
Okay, that's good. Okay, that's all I have. Thank you.
Thank you, sir.
Yeah, Vigneshwari, amazing. Thank you so much for your thought process, and then really, it's going to add value for the industry. And I know that CDAC, it's always you do the collaborations with the institute as well as the industry. On the quick note standpoint, so if you see this current trends where we have a lot of load balancers, right? Who is taking care of all your compute engines? It's maybe the RAM, or it's maybe processor, or it's maybe your storage. That's maybe Nginx, or maybe Vanish, or Balance, or Mode Athena, or HA Praxi. So we have a many load balancers, right? That itself, that is a elastic capability of the cloud, right? If you want to bring down, scale down or scale up, it should be based on the load or based on the hit. It should be go up, right? That's what ultimate requirement of the cloud. Of course, in terms of the Kubernetes, also one of the component, right? In terms of optimizing the resource, what it is really demand it is coming, and from there how you can provide or we can onboard the respective resources. So then my question is like how you are differing from the existing systems, because from this areas like already we have it, like that's the way we are saving a lot of bill, because instead of if you take a data centers throughout the day, just where we have to keep our servers on, right? If you buy, let us take 2 dB of RAM you are keeping throughout the day, 2 dB will be on. But in the cloud, it is not the way, right? When your load is morning 9 to 6, after 6 o'clock, you can bring down to 0. So that's auto scaling, auto scale up down. It's already exists, right? Just I'm trying to understand what would be the value additions of your thought process. Maybe any key points you would like to add it.
Kubernetes, as of now, it supports HPA and VPA. Both are already available, like horizontal scaling, vertical, both are available.
Exactly.
But maybe in my future work, I'll try to compare with existing Kubernetes and what can be integrated my existing with Kubernetes. That will be there in my future work. So.
Okay. Yeah, because that would be the great stuff actually. See, I've seen just you were putting your knowledge database on efficient resource provisioning, right? I mean, if you see the ERP, Most of the cloud environment, they have the inbuilt the ERP systems, which takes care of so each and everything, not only on compute engine, in terms of network optimization also. So I may have a 1 gigabits card, but I wanted to overshoot maybe one more 100 Mbps or something. Then by default it will get added 2 gigabits of network card. So that's level of scaling up. It is already in place. Just I'm giving
forecasting of workload is what has been highlighted in my paper.
Okay. No, what I'm saying is the scaling up and scaling down in terms of resource. So
now, automation of scaling, it is there already, but how earlier we are detecting the future workload and how in advance we'll be able to provision those resources is what I'm aiming to do.
Great, Vignesh. Just have a look and focus on that. Because just industry, what they are using also, you should be, considering.
Correct.
And then on that, like, what are the problem statements? So maybe if you go to the consultation with any of one, or maybe you can do the deep dive of the real-time papers. So you will get to know that, because that's already things are there. On top of that, what is the value additions in terms of the algorithms, just what you brought it, that, add values over there.
Okay.
Okay, amazing. Thank you so much.
Yeah. Thank you, sir.
Thank you, Ignishri. The next paper is Secure File Storage and Sharing on Cloud using AES Encryption Scheme for various application by Jayaraja, Manimeglai, Ravichandar and Dr. Chamundeshwari. Jayaraja will present the paper. Jayaraja?
Yes, sir.
Yes.
You hear me?
Yes, yes.
Just a minute. Sir, could you see my screen?
Yes, yes. Proceed, Jayaraja. Yes.
Yeah. So, yeah, good afternoon to one and all present here. So, I myself, Jayaraja, along with Manimeglai ma'am and Ravichandra sir, is here to present the paper on the title Secure File Storage and Sharing on Cloud using AES Encryption Scheme. And thanks to Dr. Chamundeshwari for all the support provided. So, yeah, to start off with the abstract. So, although a lot of advances has happened over the last many years, safeguarding of digital information has been a major concern all this time, where somehow or the other an intruder would get access to the data if no proper secure mechanisms aren't used to safeguard it. So to overcome this situation, we have developed a web application where users will be able to encrypt or decrypt a file and share it among other users within the same organization. So by using one single password, so a user need not maintain multiple passwords for each file that he wishes to encrypt. So yeah, with respect to start off with the introduction, so cloud-based systems are being used widely. Yes,
Jayaraja, you skipped this introduction.
Sure.
Do your work.
Okay. Yeah, with respect to the proposed system, so we are using three different algorithms here. So one is AES, which is called as Advanced Encryption Scheme on standard. So here the data that we wish to encrypt is being divided in is being converted into a multiple of 128 bits, and a key of 128 bits is basically being used to encrypt by taking different blocks separately. So, and the second one that we use here is bcrypt, which is a kind of hashing algorithm which is used to hash the password that's been stored in the database of the user's account. And then finally, the Diffie-Hellman key exchange protocol, which is used to share the file keys between each user. So where each user will have a private key which would be accessed only by him, and a public key which could be accessed by all the users within the organization. So yeah, this is basically the user interface of the sign up page. So So basically, whenever a user wishes to create an account, he would basically enter some of the standard details, which would include the account password as well. So when he clicks sign up, so what happens is, so the user's account password is being hashed using the bcrypt algorithm, and then a private key and a public key is being generated. So now the public key could be accessed by all the users in the organization, whereas the private key is being encrypted using the user's account password using AES encryption scheme, so that no other users will be able to access it. So yeah, with respect to the login, so when a user wishes to enter into the system, he would enter the password. So now the entered password would be hashed, and it would be compared with the password, that is the hashed value stored in the database. So when they are equal, we could get to know that the user is authentic, and we could give him access to the system. So these are some of the different features that are available in our application. So a user will be able to encrypt or decrypt a file. So and also share files between other users within the same organization. So yeah, with respect to encryption of a file, so a user would just upload the file and then enter the account password. So what basically happens here is, so when a file is being uploaded, a unique 128-bit key is being generated for the file, which is used to encrypt the file's content. So now using the user's account password, the file's key is being encrypted using AES encryption scheme. That is both the way of both different encryption uses AES here to encrypt the file's contents as well as the file's key. So here using one single password, we could encrypt multiple files. Yes, sir.
Yes, you proceed.
So yes. So and with respect to decryption, so decryption of file is basically the reverse of encryption, where when the user selects the file and enters the account password, it could be used to first decrypt the file's password, which was being encrypted previously, and then using this decrypted file's password, we will be able to retrieve the file. So now the user will be able to view the file's content. So yeah, and also a user will be able to share the file that he has encrypted to other users within the same organization. So in this context, we have basically used the concept of Diffie element. So basically, what happens here is the user would select the file that he wishes to share, and as well as he would enter the account password. So using the account password, he will first in the backend, it would retrieve the a user's private key by decrypting the private key using the account password, which was being previously encrypted, and as well as the files key would also be decrypted. So now using the concept of Diffie element, so using the private key of the sender and the public key of the receiver, a secret shared key will be computed. So which now that would be used to encrypt the files key. So now that encrypted files key will be shared to the receiver. So yeah, the receiver on receiving the encrypted files key, he would use his own account password to retrieve his own private key, and he would use the receiver's public key to that is to compute the secret shared key. So now using the secret shared key, he will be able to decrypt the files key that was being shared by the sender. So now using this decrypted key, he will be able to view the file that was being shared by the sender. So and yes, and also with respect to the experimental results, we tested with different file sizes, which varied from 10 MB to 200 MB. So yeah, with respect to 10 MB, it took a very less time of around 0.1 second, and of course with the decryption as well, it was almost similar. But whereas when the file size got increased, it went up to, with respect to 300 MB, it went up to 3 seconds, and also um, uh, whenever a file is being encrypted, so it is being converted to some kind of text format. So basically, the file size of the encrypted, the file size when the file's contents are being encrypted is a bit higher than the original file size. But whereas on decrypting it back, we get back the original size. So yeah. And also with respect to the future scope, as of now, we'll be able to use only within one single organization, where a user will not be able to share files with files between other users who's not within the organization. So basically, I think in the future we could develop some kind of mechanism to share files between users who's not within the organization. So yes.
Jay Raja, I
Yes,
have few questions. See, actually, you say that you are using a unique key. So you are using a AES algorithm and generating a unique key for sharing that among the organization, right? Sharing among
yes,
the people. Okay.
yes, ma'am.
And for file encryption, you're using, I mean, for authentication purpose, you're using decrypt. And then for securely transmitting the shared file, you're using the Diffie-Hellman key exchange technique.
Yes,
Am I right?
that is
Okay.
just the key is being shared using
So now in this case, how do you say that your sharing using of AES algorithm or Diffie-Hellman key exchange or whatever is highly secured? You say that it is a secured mechanism, but
yes,
this you have to prove with some attack. Okay.
But
so
yes.
if the you should mention about some of the attacks which is very often taking place in sharing of files. And so you can choose any one attack and then try to prove that it is secured. So with attack, what is your decrypted value? That is, what is your packet? I mean, the outcome and outcome of the message. And without the attack, what is the outcome? So if you try to explain it and prove with an attack, and how even though attack is present in the network, how you are able to overcome with such algorithms, encryption algorithms. So that will be much better, I feel.
Yes, sure,
and the second question is, if the key is compromised, you're using just one key for sharing to the entire organization. If that one unique key is compromised by an attacker, then the entire system will be compromised.
Yes.
So how do you it is a challenge. Okay, so how do you address that issue? So can you just explain?
I think with respect to attack, we haven't tried out yet, because from whatever I learned, AES is considered to be as one of the strongest algorithm which has not been broken till now. Previously, we were using DES, but it was being cracked a few years back. So then AES came and it was being proved to be as the strongest algorithm. So I think I could work out on that. And
yeah, definitely that is as per the literature. Okay.
Yes, ma'am.
But
So,
when you are trying to come with the results, then definitely it will be much better if you try to prove your security with respect to some attack.
Yes.
Okay.
And yes, with respect to the files key that you are, that is with respect to the account password you are saying. So we have had a change account password feature. So whereas I think if a user feels that his password would have been went out, so he could change his account password. So basically, he need not change it for each different file separately. So what happens is, whenever he clicks that option, change the account password, and he enters the old password and the new password, so the backend would retrieve all the files. So it would decrypt the original files key using the previous password, and it would encrypt it with the new password completely. So I think if it goes out, it would be a problem. But if he feels that it would have been compromised, then I think he could use the change account password to change the password for everything.
So for each and everything, whatever you say, no, you try to implement some attack and then try to analyze the output. Okay.
Sure.
Okay. Thank you for your presentation.
Thank you.
Yes, Jayaraja, I think you have specified the different sizes of the files, right?
Yes, sir.
Did you measure anything called as an optimal size of the file that can be used for your the application of the algorithms?
I think we use Java to implement this. So
Not the programming language, but the size of the file. Size and the content of the file is also very important whenever we talk about encryption.
Yes, sir. So
What
yeah,
what was the content of the file? Sorry.
So we tested with a normal image file and then a video. So and with respect to we had a medical image as well, kind of 3D X-ray. So we were being it was in the format of .nia. So we were being able to encrypt and decrypt it. So I think we were not able to view it because it's a kind of a 3D thing. So we were able to encrypt any kind of file here. So with respect to the file size, I guess. We were being able to with the current implementation we are being able to do only with up to say 300 MB because the Java had some heap size of say heap size problem. I think on changing the configuration we could overcome that as well. I think with respect to the file format we are being able to do with every kind of thing.
And what is the best application of your algorithms, especially the methodology that you are talking about? What will be the best application of it? Now we are talking about AES algorithm that is being implemented for the encryption of the images. And you also said that you had 2 more algorithms implemented, right?
Yes, sir.
Okay, so are you comparing these algorithms or
not comparing, sir? So we are just using multiple algorithms to safeguard a file. So the AES is being used to encrypt and decrypt a file. So the bcrypt is used to store the password in the hashed format so that the admin itself he will not be able to access the password. So and with respect to diffie element, it's just a simulation of how a file could be file's key could be shared between different users. I think this could be used in any organization, say, and medical field, say a hospital or kind of so. Assume that some X-ray or scanned thing has to be shared between the doctors of the organization. So basically, I think we could use this so that only the desired user gets access to it, not everyone within the same organization. And of course,
the reason I am asking you this is because yesterday we had a presentation from one of the organization called as ML Labs, and they have a project with one of the big company, Adani Group, and they were asked, trying to find out what is the reason the productivity of employees came down. And they want to know how much is the productivity and how things are happening. For that, they take pictures of people in different places and like to know what is the distance that they cover in that specific time. They're seeing that the distance is slowly increasing. People have become more and more lethargic. Okay, so such kind of data cannot be tampered with. So when you try to do an encryption in such kind of data for especially for them, no, that will be very useful. So always try to look at finding a proper application of the whatever problem that you are trying to address. We take some data and then we try to encrypt and using multiple techniques and then try to measure it. That is okay. But where do we apply it? That is the most important thing. Why do we require that? Why do we require this kind of analysis?
So in the sense, I couldn't get to the last.
Why we need to apply this and then see whether this is good or which is not good and so
finally to get it to be used
finally
by some
the application is the most important thing because you're talking about application at the end. So
actually,
I was looking
they are trying to share the files among the organizations, sir. I think that is what he's trying to do.
Is that correct?
Right?
Correct, yeah. Yes, sir, within the same organization,
they want to share the files in a secret manner. Am I right, Jayaraja?
Yes, ma'am.
That is the application he is doing, I think, within the organization.
Okay.
So, and he's extending it for other organizations as a future work. Am I right?
Yes,
I got it.
But the data that he was talking about that they are trying to share is not a textual data. It is a image based data, and then he is talking about 3D based images, right?
Yes.
So
I think
whenever we have, yes, go ahead. Sorry.
That's what I was trying to say that we tried it with different file formats. So I think as you have been saying, we have to look at some kind of better application where we could apply this.
The reason I'm telling you is within the organization, for example, a secured way where we can transfer the designs, because designs
Yes,
are secret of the organization. So they want to transfer the
yes,
design. Is it possible for us to apply? And then when you apply that, what will be the advantage of applying such kind of technique, right? So that those two things that you need to look at. In case someone gets the same file, they want to decrypt it, how much time does it take for them to decrypt it? Or even they decrypt it, they will only get a partial information of the design like that. No, you need to look at what is the proper application over there, and then that will be really good for your implementation.
Yes, sure, sir. Yes.
Okay, right.
Yes.
That's good.
Okay, amazing,
Thank
Jairaj. Thank you so much for the great effort. Well appreciated. It's really what industries, need an art of or actually. That's why it's a
Yes.
validation. Just one quick stuff. See, from
Yes.
the industry standpoint, no, most of the places the password get compromised, right? Once you get
Yes,
password
sir.
get compromised, where we have advantage, there is a separate key management system. So that will take care of like a 2FA or maybe additional certificates, and then key will help us to avoid in terms of the penetrations. But in
Yes,
your
sir.
current case, no, you have taken the password itself as a key, right?
Yes, sir.
So maybe those points just maybe you can relook. I mean, most of the
Sure, sir.
places,
Yes, sir.
password should not be a key for the respective algorithms. Then it
Okay,
is
sir. Yes.
once you compromised your password, that itself more than enough, right? So that
Yes,
you
sir.
can
Got it.
penetrate and get into your key also.
Yes,
So
sir.
those aspects, if you have a look, then the rest of the things really look great.
Yes, sure, sir. Yes.
Okay. Thanks.
Thanks.
Yes, ma'am. It's done actually.
Is the next paper? It's the paper ID. Paper ID 29.
Good afternoon, ma'am. I'm Sachin.
Okay, please share your presentation.
Yes, ma'am. Good afternoon, ma'am. I'm Sachin Matthew from Sona College of Technology. I'm pursuing second year CSE. So today here I'll be presenting a paper on BCQR, a secure decentralized e-payment system using blockchain technology. So the problem statement I'm here to share is that these days online payments like PhonePe, Paytm, PayPal, and UPI use QR-based transaction. Though it may be a secured option, still they have a greater risk of getting hijacked by hackers. And these are centralized e-payment system. So these may cause us failure at times due to the overload because of multiple user requests is taking place. So the literature survey, we have gone through.
See, you can leave this literature survey, go to your work.
Okay, ma'am, sure, ma'am. So the proposed system, what we here share is the our aim of the proposed system is to establish a static and dynamic QR payment system. So it is a hybrid chain blockchain. It is using hybrid chain blockchain in Ethereum, which which provides a QR code that on scanning will protect the transaction behind taking place. So the system will secure by preventing attacks like node capture attack, birthday paradox attack, man in the middle attack, sinkhole attack, denial of service attack, etc. The methodology we have implemented is that we designed a smart contract that allows the user to choose the incentive which they can allocate to miners for making their transaction, while the computation and the request authentication part are done by the smart contract which we have designed. The validators on the other side, since it is a hybrid chain, both public as well as private chain is linked. In the private part of chain, the authorized people or the organization is allotted to verify the transaction that is made in the chain by the public. So while a normal user can join the network through a public blockchain, while a person who is in authentication is in the part of private blockchain that validates the transaction. So this is our architecture of the QR security using blockchain. First, the center uses QR code for transferring money, that is to make a payment. The transaction is added to the pool awaiting validation, while the transaction request is sent to the authority who authorized the transaction. On validation part, the transaction is validated and the details broadcasted in the blockchain, because all the validators would be computing on the transaction, which eventually makes it slow. So we are giving a validation part, we are giving an option that user can select where they can make the transaction. In this way, once the block is mined, or if the authorizer is busy, the transaction is moved on to next one. Thereby, the block is mined and the details is broadcasted to the network. And finally, the broadcasted transaction on verification by other validators, the transfer is stored in the decentralized ledger. This will happen within around a minute, which will make the details will be added to the ledger. The receiver gets the credit in their respective decentralized e-payment system. That is, they will get a verification in their phone. So this is the user interface. So our user will join through the customer. Customer signs up the wallet through MetaMask. Once he signs in the MetaMask, the user interface asks for if they want to be the part of validator or user. In part of validator, their identity and account is validated with their proof of ID. Then if he chooses for public, he goes for just making transaction, which is he'll just make the sign up process alone. So once the person who is chosen for validator is added to the private blockchain, while the person who chose to be a user is added to the public chain, and eventually they are made to join the hybrid chain, which is the concept of it. Which is our concept. So this is the flow of BCQI user interface using smart contracts and proof of stake consensus. This is our experimental analysis. So once the user signs up and uses the QR transaction, BCQR smart contract is deployed. Here you can see that the creation of the BCQR and the deployment you can see here. So here they'll send the request for the transaction confirmation, and once the request is accepted, on validation of the user account, the block is added to the public chain. Here you can see the details of the ledger added. This is the other experimental analysis in which, due to insufficient funds in the user account, the validator rejects the chain, which shows like user denied transaction signature. This is a smart contract code using Solidity, which we have implemented to obtain the output, which I have showed here. So conclusion is A BCQR system solves the existing problems of transparency in the centralized systems and the reliability, which makes the system where in the centralized system, we cannot rely all the time because sometimes the server might go down. So it solves the problem here. And it also solves the energy consumption in the distributed network. And also for to join a private blockchain, we need a authorization every time. So when a user like public, if they want to join the network, they can go for this if they want to be a normal user, they can go for a public blockchain, that is a user, and to be a validator, they can join the private network, which needs a validation. The proposed model cuts down the know your customer requirements, which are done by the traditional systems. And this decentralized nature of the system provides reliability for the public by serving 24/7, and it also minimizes the failure of payment process in traditional systems now. So in our future work, so as of now, Ethereum chain actually supports about 12 to 15 transactions per second. And the upcoming updated Ethereum 2.0 update is about to come in 2023. And they have stated that it can do transactions like 1 lakh transactions per second. And the BCQR scalability is completely dependent upon the blockchain it has been implemented, that is the Ethereum chain. So for now, the proposed system is entirely focusing on the securing financial technologies. Maybe in our future research, our proposed concept can be implemented to various field like medical field and government documentation process for verifying and adding details and authenticating information.
Okay, in this particular work, can you just highlight what is the novelty of your work which you have contributed? Which part of this work is your novel work?
Well, ma'am, the QR system that is we implemented, ma'am, that is securing the static and dynamic QR payment system. You see, when you go to a mall or a public place, they'll especially malls. You can see that they'll be using dynamic QR payment system. On spot, they'll be billing the system and they'll be sharing a QR code. Sometimes hacker can get into the system just with the loophole, and they can cause the failure of the system, or they can bypass the transaction using sinkhole attacks. So we'll be securing that part of the system, ma'am. This is a novelty.
That's how you're securing. What is your method of securing?
Yes, ma'am. That on that scanning of the QR code, ma'am, the transaction is forwarded. In this, as mentioned in the architecture, the transaction is taken to the blockchain validation. So this way, hacker cannot easily get into the network, even though if they're going to change the
by
QR
means of blockchain, you are decentralizing.
Yes, ma'am. Decentralizing it, ma'am. So they cannot get into the network easily or take down.
So again, this point I want to highlight. You
Yes,
have mentioned some of the attacks. So any one particular attack have you implemented in your work and have you analyzed?
Well, ma'am, these kind of attacks actually needs a large number of systems to implement, ma'am, because for denial of service attack or for the sinkhole attack, all this attack needs some sort of numbers to take down the actual node itself, ma'am. So we just referred reference papers, and one of the paper actually done all these. So we took the reference alone, ma'am, for now.
Okay, thank you.
Yeah, can you measure the implementation efficiency here? Because again, you're talking about blocking the attacks and so on. What is the implementation efficiency for your architecture?
Well, sir, the efficiency is completely dependent upon the Ethereum chain, sir, because we are providing, it's more of like a Web3 app. That's the problem, sir. That is the Ethereum. It completely depends upon the Ethereum. That's what securing the system. So the efficiency is completely dependent upon the system we implemented, sir. So we didn't go for the efficiency measurement, sir.
So you're using the security that is already available in Ethereum, or you are creating your own security added on top of it?
No, sir, we are creating our own security, sir, because Ethereum is a private chain, sir. So we are actually creating a hybrid chain out of the Ethereum chain. That is, we are implementing. So on part of public, they can actually join the network just with sign up, which secures their data. And also they don't need they don't have to input their know your customer requirements. While for becoming a validator, that is in part of a banking system, they join the private chain. That's how we implemented, sir.
Okay, how is solidity important for your project? Because I was reading your architecture and I saw solidity was also there. What are you using it for?
So solidity is used for implementing smart contracts, because so the backend process of to work a blockchain, because blockchain is a implemented system. To work on the blockchain, we need some smart contracts to make use of the system, and we implemented that using smart contracts. So using solidity, we wrote the program for the code, sir. Program for the blockchain.
But what is how do you maintain the hyperledger over here? Because you're talking about blockchains, you are talking about again smart contract, and then what about the hyperledger over here?
No, sir. No, I didn't went for Hyperledger, sir. I just implemented for now smart contract as a backend process, and we didn't go for Hyperledger, sir. But in future, we'll definitely try to implement Hyperledger too, sir. That is, use Hyperledger.
And how many members were there in this blockchain?
Well, sir, we 3 students along with the faculty from our department done this paperwork, sir. So all of the 3 my friends have contributed to this paper, sir.
So you had how many nodes?
Sir?
How many nodes did you create? Or how many logins you had?
So for just experimental analysis, I made a single transaction. That is what I have attached here, sir. For now, I just access the system, and I just made the entire process.
For this blockchain, the most important thing, multiple users are there. So definitely
yes,
everyone has a role to play, and who's going to be, and what about the world database and local database? How are you maintaining all those things? That is what you need to know. Yes.
Yes, sir. Actually, the specialty about the blockchain actually is that it doesn't need a centralized server or a storage system, sir. The system, that is the transaction data is distributed throughout the nodes, sir. As you can see.
Remember, for
yes,
you
sir.
know, you have only one node.
Yes, sir.
So which means that this is only a single instance of a blockchain. But again, the blockchain requires more number of nodes added to it, and then the same transaction has to be stored in different places, right?
Yes, sir. That is what a public ledger, sir. As I mentioned here, the block of records are stored in distributed ledger, which is available in the Ethereum chain, sir. So we can actually view the part of the transaction made in the Ethereum ledger, sir. That's what I have attached in the experimental analysis part, sir.
So you make changes in your local ledger. What will happen to the global ledger?
So when that is what when we try to tamper the blockchain, it actually rejects the block itself, so entirely. So eventually the transaction won't be added to the ledger, distributed ledger of the world database. So this is how the transaction is secured, sir.
So how many smart contracts you have created, and how many blocks you have added to your chain?
Well, sir, for now I have just added around 5 blocks to check for the validation part, sir. And smart contract, we implemented just a single smart contract, sir.
Okay.
Yes, sir.
Right, that's all I have. Thank you.
Yes, sir. Thank you, sir.
Thank you, Sachin. Any more questions, sir? We have come to end of session 3. Samdesh madam.
Yes, sir. I think we can close the session and yes, Manimeghale. Bala sir, you can close this session.
Yes, ma'am.
Sir, we can take a photo with all the participants over here. You can close, Sachin, you can close your presentation so that we can take a photo. Can all of you open?
Switch on your camera.
Switch on the camera. No, you take money. Yes, all of you come to the camera. Switch on your cameras. All the participants. No, some of them are joining. You're able to take it? Okay. Yes, Manime.
Okay, thank you participants and thank you delegates for sparing your valuable time with us. Thank you.
Sir? Hello?
Yes.
Am I audible?
Yes, proceed, Manimeghale.
Yes, sir. Yes, sir. After we have keynote address, we have valedictory function. I request all the participants to present without fail. I should present. In that, we have to announce the best presentation. So I request all the participants attend the function without fail, valedictory function without fail. Thank you, everyone.
Thank you, ma'am.
And
Thank you,
I
ma'am.
request all the participants to fill the feedback form.
Ma'am, feedback form needs permission, ma'am.
Yeah,
we are not able to read
you
it.
will send the mail and you have to send through the mail, ma'am.
Okay, ma'am.
Thank you, everyone.
Thank you, ma'am.
Thank you, sir, and thank you, ma'am.
Okay, thank you.
Thank you, sir.
Thank you.
Thank you, ma'am.
Thank you. Thank you.
Thank you. And 1 o'clock we have the next session. Please, all of you join. We are running short of time, so no break. So please, all of you, I request you to assemble here at 1 o'clock.
Thank you, ma'am. Thank you, sir.
Yeah, thank you, Bala sir.
Thank you, sir.
Thank you. You
Yes.
switched off the recording, sir. We're done.
Yes, sir. Yes,
Right, sir. Thank you. Thank you for inviting me, sir.
Sure, sir. We'll catch up, sir.
Sometime we'll catch up, sir. That's what.
Yes, yes.
Thank you, Dr. Chamdesri, madam. I think she is also busy. And Dr. Suresh, sir, thank you so much.
Yes, sir.
Suresh, sir is joining from somewhere, I believe. So
yes, yes, sir.
Yeah, thank you.
Sure,
thank
sir.
you also. Sometime we'll see, sir. Thank you.
Sure, sure, sir.
Hello.
Tell me, madam.
Okay. Sir, next speaker line la irukkaru oru nimisham sir.
Yeah.
Hello.
எல்லாம் போயிட்டாங்களே. ஃபீட்பேக்லாம் பாருங்க. இங்க ஷேர் தான போட்டுருக்கீங்க.
Hello, can you hear me? Hello, can you hear me?
Yes, we are able to hear you. So for you, it is good morning. So we are here in the afternoon session. Can you hear me?
I can't hear you.
Oh.
Just a moment. I'll try to.
Or increase your volume. Can you hear me now?
Just a moment.
Okay.
Again, talk. Can you talk?
Can you hear me now?
No, it's okay.
You are able to hear me?
Yes.
Okay. So here I said that it's good morning for you, and we hit good afternoon for us.
Good afternoon. Good morning here. Good afternoon.
Yeah, in your place, it's good morning.
Yes.
Okay.
So let me start to share my presentation.
Okay.
Okay. Okay. Can you see?
Yes. We are able to see it.
Okay. So good morning from Egypt. My name is Islam Amir. I'm professor of computer science, work at the Faculty of Computers and Information and Masr International University in Cairo, Egypt. Really, I'm happy to share these minutes with you, and I hope that you my presentation become interesting to you. This is my contacts. So let's start.
So can you put your screen in the presentation mode?
Can what? I'm sorry.
No, can you put your screen in the presentation mode?
I didn't put a present. I make a presentation, and I'm sorry. Can you see my presentation?
Yes, I'm able to see your screen. No issues, but you have to put your screen in the presentation mode.
I'm sorry. I'm sharing my presentation. I don't
No,
know
no.
what happened.
No. Everything is fine. Fine. But only one thing is that you have to put your screen in the presentation mode.
My screen?
Yes, in presentation mode.
Uh-huh. Okay. Okay. Okay, I understand.
Ah.
Okay. So let me first unshare it first, and because I know it's okay. Just a moment. You mean full screen? Okay. Like that. Can you see?
No, not that.
Can you see right now? I don't know what happened. I see here, this is complete. This is a presentation, and this is just a moment again. Okay, stop sharing, and I will share my presentation. Okay.
No, what you shared is right. Only thing is that you have to put your screen in the presentation mode. That's it.
Yes. That's what I did. That's what I did, but I don't know what happened.
No. I just do it again.
Okay. Share. Can you see right now?
No, not yet.
Not yet. Okay, so this is the last option for this PowerPoint presentation. So I make it appear as a PDF file, and then I can, yes, that's all. So I will stop this and this, close everything, and then I'll share, okay, the full screen mode. And now it's time to share this. Okay. Is it okay now? Can you see?
Yes. Yes, good.
Okay. So let's start with our agenda today. So I'm going to what's malware and current malware analysis methods, and I will talk about the drawbacks of current approaches, and I will present my static approach I did, and once more the dynamic approach I already did, and I will talk about the malware mimicry. So I hope that the presentation will fulfill the people requirement or what they expect to say. So what's a malware? Everyone knows that the malware is a malicious software which is intended to cause harm or cause damage on computer systems. And there exist many different families and many kinds, like virus, trojans, worms, adware or spyware, ransom, and so on. And when we want to see how the malware affect the economy, So you can see, according to Kaspersky report, that the malware has been increased by 16% in 2000, for example, 2018 compared to 2017. And one of the most targeted country was Russia, which is the attacks was increased by 22,000, and especially the target banking accounts. Following Russia is Germany and India, about 404%, in Vietnam and Italy and the United States and China. So they found that the number of users, our customers, who encountered Android banking malware was tripled to 1,707,891 worldwide. So you can see and expect the economic effect of malware over the customers and users in the whole world. And when we come to the malware detection or malware analysis technique, we can find that it falls into two categories, either static or dynamic. Most of the current conventional antivirus employ static approaches, which means they rely on signatures or some patterns that they can extract from the malware files. However, in dynamic malware, the analysis rely on investigating the behavior of malware in a secured environment, like sandboxes. Both methods have has advantages and disadvantages. So when we come to the problems with the signature or static techniques, so there is no generalization capability to novel threats. Actually, each threat is considered new threats is considered new. They don't know any signatures regarding to that attacks. Therefore, they need to investigate again these threats and they generate or extract some signatures from that. And one of the most problem in these signature is that require reverse engineering to write new signatures. And these signatures can be escaped or bypassed by malware authors if just change with minor variation in the signatures or in the malware. They can skip by from being detected by the antivirus. So the problem is that they can't generalize any solution to that type of static analysis. In the dynamic analysis methods, although it's efficient, but if you want to analyze the malware, each sample require amount of time to extract some behavioral features. Therefore, it's very slow compared to static analysis. And some malicious samples can run out of the clock on behavioral checks, which means that in some smart malwares can detect that they are investigated in a secured environment or a virtual machine, so they can actually await their malicious code to be run. Therefore, this is one of the problems in dynamic attacks or dynamic analysis, I'm sorry. And one of the problems is that the dynamic analysis techniques are vulnerable to false positives or false negative results. We proposed actually two solutions or two approaches. First approach is utilizing static analysis. We proposed in simple detection model. And the second approach is we employ dynamic analysis features such as API, and we publish that results. So in the first solution, what we aimed at is to propose some ensemble method which is composed of the most influenced classifiers that can detect the malicious features in databases or in threads. And through these classifiers, we used or select some candidate classifiers to form an ensemble model. And this ensemble model used to tested against unseen data to classify it whether it's malware or goodware. We used some databases, data sets from for malware and benign-ware or goodware, and this is the quantity and the numbers. Okay, the data set was composed of 54 features, and we used the random forest to select the top 10 features, which we found that significant. So we reduced the amount of data set to 78% compared to the original results. And these are the selected features which can appear in the header, PE header for a file. Some accuracy results, we can find that our proposed ensemble method is working good compared to other machine learning approaches. And we combined our ensemble model with some stacking with another models, and we found that its accuracy is increased and the false positive rates are also decreased. Again, we tried to combine our ensemble model with different classifiers, and we found it's actually it's become stable somewhat. Although the detection accuracy may be found marvelous and good, but as I said, don't be taken by such accuracy, because we trained them or we use the model that is extracted from some data set. And as I said, that there is probability, or that with minor change, some features become less significant and some others become more significant. So in static analysis, don't be taken by the results. Therefore, we switched to dynamic analysis method, and we have to answer some comments or some problems regarding to the dynamic analysis challenge. One of the most important challenges is the number of individual API functions. We employ the API functions is considerably huge, which make it difficult to analyze. You know, the behavioral, when you run the malware, in a secured environment like Sandbox, we try to extract some behavioral features. One of the most important features in dynamic analysis is the API call, which is the interaction between the process and the operating system. Actually, the operating system is responsible for running your process through calling some functions which indexed in the dynamic library, the DLL files. So these files, when you run any process, this process is converted to a sequence of API calls, function calls from such DLL files. Okay, so if you want to run sample program, so this interaction is result in a sequence of API calls. And actually, the operating system doesn't differentiate between the malicious and normal process. It's actually considered a process, whether it's malicious or not. And this process is converted to a sequence of API calls. The outcome of such a process, if it's malicious, will appear later, but the operating system cannot decide from the first glance or from the first moment if this process is malicious or not. So it's just a process. So the problem here, and this problem is one of the things that malware authors rely on, that is the number of individual API functions is considerably huge. If you can think about the number of API call in some process, it's not just 100 or 200 or 300 call file or API call. No, it can be up to 10,000 or 30,000 call in length. So it's hard to analyze. And another challenge is that malware usually tries to escape from being tracked or detected by adding a large number of unneeded API calls. So the main objective here is to add some events which looks like normal to hide its malicious behavior and make the analysis process more difficult. Okay. So we want here to overcome such a challenge. So we propose our method here, which consists of 3 steps. The first step here is the initialization phase. And here, the outcome here is, or the objective here is to convert the API calls for malware or goodware into more or to some numbers, that small numbers. These numbers are consisted of what's called cluster numbers. So we want to customize these API calls into some type of clusters. And to perform that, we trained, or we used the API calls for malware or goodware, and through word embedding, we group the API calls that related to each other in malware and goodware. And here we said that because they are relied on the same DLL files, so they may be related to each other in some way, depending on the current process. If the process is malicious, therefore the interaction between the API calls will be, of course, different than the interaction in malicious one. So therefore we have 2 models, 2 embedding models, and we used these 2 embedding models to calculate the similarity between the APIs in 2 categories. And after that we have 2 goodware API similarity matrix, which is n times n, where n is the number of APIs, and the ij of each matrix is the similarity between the context similarity between API I and API j, for example. Okay. Therefore, after having this matrix, we use the key-means cluster to cluster these similarity matrix in 2 numbers of clusters. So we have now goodware clusters for the goodware API calls, and malware clusters for the malicious API calls. These clusters will be replace the API that's indexed in. So we use these clusters as the calling number for the API its index instead of the API itself. Therefore, the number of clusters here, so the API finally, the initial API API call sequences are converted then into a sequence of cluster calls. We use these cluster sequences to create a Markov model through maximum likelihood estimation. We created two transition models, or 2 Markov models, and based on that, we created a Markov model for the goodware model and the Markov model for the goodware model. And we used these goodware models to validate or to test whether the sequence or new sequence is goodware or malware. But here we perform something else, is to make some kind of reformulation for the sequence, which will appear in the example I will present right now. So here we find this is data sets that we used. This is all of them are available. And this, for example, is a sample of API call sequence for a malware called worm.win32.zwr.c. This is a sample, a small sequence actually. So this is small sequence, which is consisting of API calls, is converted to cluster sequences, which is like that. Which means here is that get system directory A, which is an API, is located in cluster 1, and the SDBCS lead byte is indexed in cluster 2, and so on. So each API is replaced by the cluster at index. And as I said, we use these cluster indices here for the all training data set to create the transition, the Markov model by calculating the maximum likelihood between these clusters. And we have here, for example, the malware cluster, the malware clusters transition matrix. Here, this is the zero, and the rows and columns here are corresponding to the transition probability between cluster. For example, cluster 1 here, because it's from 1 to 0 to 9, it's actually 10 clusters, so it's from 1 to 10. So 0 here, it means 1. So cluster 0, for example, 0 to 0 is 0.75, and so on. This is considered a full example. So when we have an API call sequence, we cluster them and cluster the API calls and replace API call by the cluster it contains. So this API call sequence is converted to cluster sequences like that, for example, and then we constitute the transition sequence for that cluster sequence. So we have here probability of 1 to 1 and 1 to 1 and 1 to 1 and 1 to 4 and 4 to 4 and 4 to 1 and so on. And these this transition sequences is tested against goodware cluster transitions and malware cluster transitions. And based on that, each one here for example, probability of 1 to 1, which means 0, 0, for example, or is can have two values here. Two values, value for goodware cluster sequences or cluster transitions, and one for the malware cluster transitions. And based on the maximum here, if we have it, if its probability in the goodware is greater than the malware, so we put 1. We put 0, which means it's not malicious. And if its probability in the malware is greater than its probability in goodware, we put 1 for the probability. So the formulated sequence here is become 1, 1, 1, 1, and so on here based on this probability. Okay. Again, we use the formulated sequences for the malware and goodware to create a tiny transition models for goodware and malware models. Here is the transition model for goodware, and here's the transition model for malware. And based on the analysis for these models, we calculate the maximum cumulative likelihood between the malware sequence given malware and the sequence given goodware. And based on this value, this transition or the sequence is regarded or is classified either it's malicious or non-malicious. Some experimental data for our accuracy of detection, and we can find that we have good accuracy in terms of 0.990, and with false positive and false positive rate 0.01. And also we try to make some type of prediction. Instead of relying on all sequence, we try to find, for example, if we just investigate the first K API calls, how it can perform, how our system or our model can perform. So when we investigate the first, for example, 10 API functions in the sequence, this is the average precision. It was 0.756, and if in terms of accuracy, it's 0.839. However, when we increase the number of API calls in the sequence, the accuracy is increased. It become 0.880. And once more, when we added the prediction for the first 30 API calls, the accuracy actually enhanced a lot. And for the first 40, it enhanced. So it means that our system can enhance its prediction method given some amount of API calls. When the API calls number is increased a little bit, and it's not all the API calls, but with some API calls, some snapshots for the API call, we can predict for the given sequence whether it's malicious or not, which means that instead of awaiting the whole crisis to take place, we can predict from some snapshots of this sequence that this process is malicious, so we can stop it from the first or from the initial moments. However, there is some problems that may happen, which causes also such false positives, what's called mimicry malware or fake goodware detection. Actually, some malicious processes acts as a goodware. However, they are not goodware. They are malware, but they appear to be goodware. For example, this is a sequence for a malware, and this is a sequence for one of the goodware that actually this is a malware also that appear as a goodware, or our system classifies it as a goodware, whether of course it's a malicious also. But how can we detect such mimicry activity? When we investigate the malicious sequences against the malware model and goodware model, we found there is a gap between the performance of malware and the performance of the sequence in the goodware transition models. So there is something or some type of gap between each activities or each transitions. However, in terms of the mimicry or the fake goodware or the mimicry malware, we find that the malware change its behavior. So there is some intersection points that take place in this execution of the processes. This changing behavior is we can say a warning of a mimicry activity, which means the changing behavior, changing its behavior or changing the process type. It appear, for example, as a goodware, and then it changed it as a malware. So I just provide here with some sort of a small lens snapshot. But if we find it, if we have a good a big snapshot, we can find that there is a lot of intersection points between these behaviors. So we find that it is a distinct behavior or a discriminative behavior between post activities or post representation. And we come with a model that based on called behavioral intersection ratio. It's in here for typos. Based on such a relation, we can find that or we can estimate whether the sequence acts as mimicry or not. I don't know why this table that's it's missed here, but actually, according to this equation, we found that we overcome and solve 0.993 of the false positive. We can detect about 0.993 of the fake malware samples, which means we open the area now to detect.
I have a doubt. Like, how do you say that there is a behavior change in the malware? The previous graph you were showing. So how was the change? Why? How? What do you mean by change here?
Okay.
Yeah. So can you give some examples like how this situation can arise?
Yes. Okay. Let us investigate, for example, this sequence. Okay.
Please proceed.
So this sequence here, actually it's malicious because it contains 11111101111. It's malicious. But so this malicious value, when you test it in the goodware model and test it on the malware model, so the transition between the 1-to-1 and 1-to-1 and 1-to-1 and 1-to-1 will bring the summation of probabilities here will be great here in the malware model. However, if you tested that in the goodware model, the summation of probabilities will be not that big compared to the malware model. So it means here that the sequence, the operation for the sequence in malware model will output a cumulative probability, accumulated probability greater than, value greater than the one it accumulated from goodware model, which means there will be a gap.
See, I understand, but how this is possible? So can you give me one scenario how this would have happened? How your model is able to categorize that? So one scenario.
One scenario?
Yes. How this has happened?
I can simply, if you can run a PDF file which contain a macros or something else. It's a PDF file or it's an image or that contains some malicious code. So you download the image or the PDF file because it's safe to download the PDF file. However, it contains malicious macros.
Okay, no, what I have my doubt is that you were showing one graph. Just please go to that graph. Okay, you are giving some inputs. Okay, based on the malicious, you will be getting 1111. Okay,
yes.
But in the graph, you were talking about there is a change in the behavior.
Yes.
So, you mean that that is a part of a time there will be malicious and a part of a time you will be getting a non-malicious input so that there is a deviation or something else is there. So that's what I just wanted to hear from you.
Okay, so let us think about this. Can you see the cursor?
Sorry?
The cursor,
Yes, yes.
the mouse.
Yes, yes, yes.
Okay, for example, let us think about this sequence here.
Okay.
The sequence is appeared as malicious in some part and good were in other parts. This is a real example, by the way. This is a real example. Okay, I'm not typing it from my this is a real malware sample, by the way, or some snapshot of a real malware sample.
Okay.
So this is how our system formulates this sequence. Our system classified that malicious or this sequence as goodware sequence. It's benign sequence. However, it's not. It's not. Okay. So when we investigated this sequence, we found that it's classified as goodware because of the number of goodware transitions 00000, which is not malicious. Part of that is malicious, but the accumulative probability for this sequence will tend to be goodware. So it's not malicious one compared to the one on the left. Here is the majority of transitions is 1. However, with some minor zeros, but it doesn't affect the whole accumulated probability. But here it affects that probability. Therefore, when we investigated here this sequence against the malware model and the goodware model, here, the twos here, okay, we found that the sequence, when you provide it to the goodware model, what is the outcome of it? The outcome of it will be change here. For example, this is the sequence. The red one is the goodware, and the one here is the malware, the blue one. So the blue one is increased in the first glance, in the first moments, and then it become like that, and the goodware one starts to increase at some moments, and then there is some intersections that happen between them according to the accumulated probability. Here is accumulated probabilities. Accumulated probabilities increased, and here is increased. By the time at some point we will have some mixed behavior between the malware and goodware. Therefore, we can think about that as a mimicry activity that's produced by the process. We tested it over thousands of processes, and we found that the malware that acts as explicit malware, the gaps between the models will be like that. And when there is a goodware, there will be a gap also between the malware activity and goodware activity according to our models. But when we have something like that for a mimicry malware, we found that there is intersection points or changing behaviors at a lot of points during its execution. So we found that the mixing behavior, and it's not just once, it will have some kind of a lot of intersections. I just make someone here for clarification, but in general, there is the intersection between the blue and red are a lot intersection points. So we found that it's acting as a malicious activity, malicious mimicry activity. So to finalize that, we introduced a novel malware detection and prediction approach based on the API call sequence. We proposed a method for efficiently analyze the huge number of individual API functions, and we found behavioral discoverable differences between normal or benign and malicious API call sequences. And we finally proposed a method to effectively detect malware mimicry. I finished my presentation, and if you have any questions, I'm happy to receive it. Thank you.
Participants, you have any questions? Okay. Thank you, sir. Thank you, Aslam Amir, sir. Thank you for your valuable address. Thank you very much, sir. Okay. Participants, we will be resuming here at 2 o'clock for our valedictory function. Thank you, everyone.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
So, thank you. And have a nice day. Bye.
Yeah. Thank you.
Thank you. ஜாயின் பண்ணுங்க. ஜாயின் பண்ணுங்க. உள்ள வாங்க.
Bala sir? Bala sir, can we start, sir?
Yes, madam.
Good afternoon, everyone. Now we have the valedictory function. For that, I would like to welcome Dr. A. Chamundeshwari ma'am, Professor, CSE Department, SSN College of Engineering, to announce the best paper.
Thank you, authors, for all of you for presenting a very good work in this conference. And I hope that all the authors got the good inputs for their work, research work. And we evaluated the papers based on the criteria. So based on that, we have selected first papers and the second paper. So the two papers are on that list. So the first one presentation, first very good presentation, and the scoring was very good for the paper ID 28. So the authors are Pooja Premnath, Sanjay Balaji, Prahlad Rajagopal. And the second one is paper ID 21, Vigneshwari and Professor K. Murugesh. So I congratulate and thank and all the best for your future research work. Thank you.
Thank you, ma'am.
Thank you, ma'am. And I would like to congratulate the selected paper authors. Then the time for vote of thanks.
No, can I ask the feedback?
Yes.
Vigneshwari is not there actually.
Yes, Vigneshwari, I think you are here. Can you give the feedback?
Yes, ma'am. All the sessions were very informative. Actually, I get a lot of inputs from keynote speakers as well as the session chairs.
Can you come in the video first?
Yeah, sorry.
Yes.
Yeah, good afternoon. All the sessions were informative, especially the keynote addressed by different personalities. So I get a lot of information, and in the even session presentation also, the chairperson were interacted with all the authors, how to improve their paper, how to approach, first of all, how to approach a paper and all that. So it is very informative. Thank you for being part of this.
Thank you. Jayaraja, can you share your feedback?
Sir, it was really great. I think this was my first conference that I'm attending. So, although it was just a start.
Jayaraja, can you come in the video? Can you come in the video?
I think I just connected from my mobile.
Okay, proceed then.
Yeah, so yeah, although it was just a start, they gave a lot of feedback, so it was really very good. I think it would probably help me to go further.
Thank you, Jayaraja. Manimekla, you're on mute.
Yes, sir. Yes, sir. I'll proceed. Now the time for vote of thanks. To deliver the vote of thanks, I'd like to invite Dr. V. Balasubramanian, sir, Associate Professor, SSN College of Engineering, CSC Department. Sir, please.
Good evening, all. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. I would like to thank all the honorable delegates who blessed us with their presence. I'm also very much thankful to all the program committee members and the invited speakers. Words are not enough to thank their constant guidance and support to shape this conference. I, on behalf of the organizing committee, convey my deep regards and hearty thanks to our honorable principal, Professor V. Annamalai. He helped us in obtaining the necessary administrative approval for organizing the event, and he supported in all possible manner to organize this conference. My special thanks to Professor Ulrich, Professor, University of Koblenz, Germany, for his gracious presence by coming and participating in this conference in physical mode. At this juncture, I would also like to thank Mr. Omar, the President of the National Commission for the Protection of Personal Data, Morocco, for gracing the occasion and delivering the keynote talk. Also, I would also like to thank all the keynote speakers, Dr. Anthony Wong, who is the President of International Federation for Information Processing, for giving a keynote talk. Also to Dr. Mr. Navanithan, Senior Vice President and Chief Information Security Officer at GROW, for giving a keynote talk. Also to Dr. Jagdish Chundri, Senior Technical Leader, Cisco, Bangalore. And also to Dr. Islam Amir, Misr International University, Egypt, for accepting our invitation to give a delivery talk, keynote talk. And I would also like to thank our beloved head of the department, Dr. Mirnalini Madam, for her constant help and guidance that radiated a source of energy within us. We will ever remain grateful to you, and we thank you for being with us today. I would also like to thank all the session chairs, and I'm very much thankful to all our faculty colleagues and non-teaching staff members who always stand by us and motivate us. I feel proud and thank you for making this event a grand success. Thank you all of you. Thank you all of you for making this event a great successful event. Thank you all.
Thank you, sir. Thank you, everyone. Participants, you are requested to fill your feedback form for your certification process. You have to fill and send the feedback form as soon as earlier. Thank you, everyone. Thank you for your support.